Welcome, this is Emmett, and in today's video we'll be tackling this problem. For more unique problems Mari and I created and solved, visit the link in the description and check out the rest of our videos. Okay, so determine the area of the shaded region of this circle. So pause, try it out, and get back to the video when you're ready. So the problem with this problem is there isn't much guidance, it's just a diagram. So we have to figure out where to start. I'm going to try and recreate this diagram in the XY plane since I see we have to find an area and we'll probably want to use integration. So starting with the circle, I see that the diameter here is 4, meaning that the radius is going to be 2. And using the circle equation, x squared plus y squared equals r squared, we get x squared plus y squared equals the radius is 2, so 2 squared. And this centers the circle at the origin, which makes things easy. And I'm going to draw this over here. So now to isolate for y, we can subtract x squared for both sides, and we get y squared equals 4 minus x squared. And then taking the square root of both sides, we get y equals plus or minus square root of 4 minus x squared. However, because we only need the bottom portion of the circle, because as you can see over here, we're only going to need to be working with this area, so we only need this part of the curve, the negative portion, we can just use negative square root of 4 minus x squared. So y equals negative square root of 4 minus x squared. Now we can figure out how to integrate. What I see is integrating with respect to x from here to here will give this entire region right here. That's not perfect, but luckily, if we look at the original drawing, this area that we don't want right here is a triangle whose area we can find and then subtract out afterward. So let's get the two areas. So since this distance here is 1 and this entire radius here is 2, we're going to be integrating from x equals 1 to x equals 2. So let's do that. We have the integral from, I'm actually going to switch to black, we have the integral from x equals 1 to x equals 2 of negative square root 4 minus x squared dx. And so you can try doing this by hand, but I'm going to use a calculator since integrating this by hand is quite tedious. And my calculator yields negative 1.228. Now, although this area here is negative, since in the way we solved it, the area is under the x-axis, the original diagram here doesn't have any axes and doesn't indicate that it should be negative. And so what we can do is just treat this area as 1.228. And so now all we have to do is subtract out the area of the little triangle. And so the base of the triangle, this length here, is going to be 1, since this entire length is 2, and this length is 1. And then this length right here is going to be 1/2, since this entire length here is 1, and this is going to be half of that length. And so subtracting it out, we're going to subtract 1/2, and then base is 1, and then height is also 1/2. And so that's going to be 1.228 minus 1/4, which yields 0.978. And that's the answer. Once we found the method we wanted to use, this was pretty straightforward. And if that was too easy, you can try also solving this with polar integration instead. So thanks for watching and have a nice day.